The Great Pyramid of Giza is 481 feet tall. It contains 3 million stone blocks. The heaviest weigh 80 tons. When it was finished around 2560 BC, it was the tallest structure on Earth, and it would hold that title for the next 3,800 years. The question that has never fully gone away is simple. How did people without steel, without wheels, without cranes, and without any form of written engineering manual actually do this? Not aliens, not lost technology. The real answer is more unsettling than either of those, because it requires accepting that a civilization 4,500 years ago had solved a series of logistical and physical problems that experts are still piecing together today. Start with what everyone gets wrong about who built the pyramids. For centuries, the standard story, the one Herodotus told in the 5th century BC, the one Hollywood repeated for decades, was that Hebrew or foreign slaves were whipped into building Khufu's tomb under brutal conditions. That image collapsed in 1988 when American archaeologist Mark Lehner of Harvard's Ancient Egypt Research Associates excavated a settlement at the foot of the Giza Plateau, now called Hayt el Ghurab. What he found was not a slave camp. It was a city. A planned, organized settlement containing bakeries, breweries, administrative buildings, and workers' barracks. The bones found in the settlement's refuse piles were mostly young male cattle, prime beef, the most expensive protein in Egypt. The workers buried near the site were interred with grave goods, and honor ancient Egypt did not extend to slaves. The men who built the Great Pyramid were paid workers, organized into rotating 4-month teams, fed at state expense, and given medical care. The pyramid, in other words, was not a monument built on misery. It was a national project, more similar to a modern state infrastructure program than to a forced labor camp. So the who is settled. The how is where it gets strange. In 2013, a French archaeological team led by Pierre Tallet of Paris-Sorbonne University was excavating a Red Sea harbor site called Wadi al-Yarf, about 180 kilometers south of Suez. Sealed inside storage caves carved into the limestone were rolls of papyrus that turned out to be the oldest written documents ever found in Egypt. The most important was a daily logbook kept by a middle-ranking inspector named Merer, dating to the 27th year of Khufu's reign, the final months of the Great Pyramid's construction. Merer and his team of roughly 200 men had one job: ferry blocks of fine white limestone from the quarries at Tura across the Nile to the construction site at Giza. The diary describes the schedule in exact terms: 2 trips per day. A precise rotation of departure and arrival times. The papyri named specific harbors, canals, and transit routes. For the first time in history, a first-hand account of pyramid logistics existed, and it was about boats. That detail matters enormously, because moving 3 million stone blocks across open desert without wheels is a problem that borders on impossible. Moving them by water is something else entirely, but the water route only explains delivery to the edge of the site. Getting individual blocks, some averaging 5 tons, from the riverbank to their final position in the pyramid required something else. Here is where an answer was hidden in plain sight for more than a century. In the Middle Kingdom tomb of an Egyptian official named Jehuti-Hotep, built around 1900 BC, a wall painting shows 172 men hauling a colossal statue on a sledge using ropes. In the painting, one man stands at the front of the sledge and is clearly pouring liquid from a jar onto the sand directly ahead of the runners. For generations, Egyptologists interpreted this as a ritual purification. A 2014 study by physicist Daniel Bohn and colleagues at the University of Amsterdam, published in Physical Review Letters, suggested a different explanation. The team built a scaled replica of an Egyptian transport sledge, placed it in a tray of sand, and systematically tested the relationship between water content and pulling force. The result was precise. Adding water to dry desert sand at a ratio of between 2% and 5% by volume creates capillary bridges between sand grains. Microscopic water bridges that bind the grains together stiffen the surface and cut sliding friction roughly in half. Below that ratio, the sand heaps up in front of the runners and the pulling force climbs. Above it, the sled bogs down. At exactly the right moisture level, the number of workers required to move a block drops by approximately half. The man with the jar in that 3,900-year-old painting was not performing a ritual. He was doing physics. But even water-lubricated sleds leave open the problem of where the pyramid builders were getting their stone in the first place, and why the pyramid fields are located where they are, in a strip of desert on the edge of the Sahara that seems to make no logistical sense at all. In May 2024, a team led by Ayman Ghonim professor of Earth and Ocean Sciences at the University of North Carolina, Wilmington, published a study in Communications, Earth and Environment that reframed the entire question. Using radar satellite imagery, geophysical surveys, and sediment core analysis, Ghoneim's team mapped a 64-kilometer-long extinct river channel running directly alongside the chain of 31 pyramids stretching from Giza to the south. The channel had been invisible under farmland and sand. They named it the Ahramat branch. Ahramat meaning pyramids in Arabic. The analysis showed the channel was active and navigable during the Old and Middle Kingdom periods when the pyramids were built. Every causeway leading away from every major pyramid terminated at the proposed riverbank of the Ahramat branch. The valley temples, long assumed to be ritual structures, appear to have functioned as river harbors. The pyramids were not built in the desert despite the desert. They were built where they were because a river ran there. The river died, the desert moved in, and the structures remained. What this means, assembled in full, is the following. A stone block quarried at Tura crossed the Nile by boat, as Merer's team recorded in real time. It traveled up the Ahramat branch to the pyramid site, as Ghoneim's satellite data now shows. It was offloaded onto a wooden sled hauled by a team of paid, well-fed workers, across sand kept precisely damp by a designated water carrier, as Daniel Bond's 2014 experiment confirmed from a clue hiding in a tomb painting for over 100 years. At the site, ramps of undetermined configuration, the exact shape remains debated, allowed blocks to rise level by level over the 20 or more years the Great Pyramid was under construction. The workers who built it had names. Merer wrote some of them down. They received beef, bread, and beer. They were buried with honors. They returned to their villages after 4-month rotations with new skills and, apparently, status. Graffiti found inside the Giza shafts includes what appears to be work gang names written by the workers themselves, including one translated as Friends of Khufu. The greatest building project in human history was not a mystery requiring supernatural explanations. It was solved by physics, logistics, water, and an organizational capacity that modern states still struggle to replicate. The diary of a middle manager named Merer, sealed in a cave for 4,500 years, tells the story of the last 3 months of one of the most extraordinary engineering feats in the history of the species. 2 trips per day, limestone blocks, on the water, to Giza. He probably didn't know he was writing history. He was just keeping records.